All right, so let's take a look at another problem. This is a more of a real life problem where we're going to use general form to model an equation, to model a problem. So go in your textbook to page 362 and we'll read what it says there and try to figure out how to model the situation and interpret some of the information that our graph or our equation is telling us. Okay, so page 362, it says Spencer has 66 gigabytes of disk space left on his laptop to fill with TV shows and movies that he purchases online. And probably the first thing you should think is, Spencer, it's time to get a new laptop, because 66 gigabytes of space is not a lot, and you'll probably just really slow down your computer if you fill up the remaining space with movies. But whatever, okay? He's got 66 gigabytes of space left, and for some reason he wants to fill it up with TV shows and movies. So, question A here says that each TV show takes up, on average, 1.1 gigabytes of space. And just to keep the problem simple, we'll say that any TV show takes up 1.1 gigabytes, even though technically that's not true. Different shows take up different amounts of spaces. And a movie, an average movie, is 4.4 gigabytes. And we're going to let T represent the number of TV shows that he has on his hard drive for that 66 gigabytes, and M represents the number of movies. So we need an equation that would give Spencer some idea of how many TV shows and how many movies he could have without exceeding the 66 gigabyte limit. Okay? He could have all TV shows, he could have all movies, he could have some of each. But however many he has of either, he just needs to make sure he doesn't exceed this total. So we're going to use the general form of the equation of a line to model this, and here's how it's done. If you think about how you would find the amount of memory taken up by TV shows, say for instance he had 5 TV shows, you would take the amount of memory per TV show, 1.1, and multiply it by the number of TV shows, right? You would essentially go 1.1 times 5 to find out the space of 5 TV shows. That would be 5.5 gigabytes, right? So an expression that we could use to find the memory of any number of TV shows would be 1.1 times T, because T represents the number of TV shows. Likewise, if I wanted to know the amount of memory that movies took up, I would just go the amount of space per movie, 4.4, and multiply by the number of movies, in this case M. Those two amounts totaled together, the amount of memory from TV shows, the amount of memory from movies, should total up to 66. Okay, so there is our equation in general form that models this situation. Question B asks us to find the t-intercept. The t-intercept, and then interpret what it means. Okay, so this is very similar to what we've been doing last time with x and y, except now we have t and m. If I want to find the t-intercept, I set m to 0, and then I'm going to solve for my remaining variable, t. Okay, so that's what we're going to do here. Set m to 0, so I have 4.4 times 0 equals 66, so that term just basically goes to 0, and I'm left with 1.1 t equals 66. Divide out both sides by 1.1, and t will give me 60. So if you were to think of this on a graph, this line would cross the x-axis, or the t-axis, I suppose. This would be the t-axis, this is the m-axis. It would cross at 60, 0. So what does that point mean, essentially? Well, it tells you that the maximum number of TV shows that Spencer could put on his disk, if there was 66 gigabytes left, would be 60 TV shows and no movies. Notice that the M coordinate here is 0, right? So if he said, all right, I just want all the seasons of Gilmore Girls and nothing else, Okay, which I don't know, is that 60 episodes? That's probably more. Whatever, you get the idea, right? He wants 60 episodes of something and no movies. He just wants plain TV shows or just TV shows in his disk space. The maximum number of shows he can fit is 60. That's what the t-intercept represents. To find the m-intercept, we use a similar method, except this time we set t to 0 and solve for m. So this time we'll set t to 0 and solve for m. So this term basically goes to 0. I have 4.4 m equals 66. Divide out the 4.4, and I get m equals 15. Okay, so the m-intercept is this point right here, 0, 15. And what does that point represent? Well, if Spencer only wanted movies, the maximum number of movies he could afford to put in his disk would be 15, and no room left over for TV shows. Okay. Question D says that if Spencer had 16 TV shows in his hard drive, and his hard drive was full, the 66 gigabytes was all used up, how many movies would he have? Right? Well, you can see that the maximum number of TV shows he can fit is 60, so there should still be space for movies. The question is, how many movies could he fit? Well, in this equation, 1.1t plus 4.4m equals 66, they tell us the value of t, right? There are 16 TV shows. So we're going to put in 16 for t and then solve for m. So 1.1 times 16 is 17.6 plus 4.4m equals 66. And I'm going to bring the 17.6 over to the other side. And that works out to 48.4. And then we divide both sides by 4.4. Okay, and that would give m equal to 11. So if he had 16 TV shows, he could fit 11 movies. And if he did that, he would use up all 66 gigabytes of hard drive space that he has left over.